It's very likely that most of you out there have never heard of me, so a few quick things about myself. You can generally find me answering questions online in a whole bunch of different places. I am at AceMarkE or at Mark Erikson in various places across the internet. I spend a lot of time collecting links to various useful articles, utilities, libraries, and tools, mostly focused around React and Redux. I write some very long blog posts, again, focused on React and Redux. I've got one series that is primarily a tutorial series building a sample application, and another series that talks about my opinions on Redux best practices and good usage. And I am a co-maintainer of Redux, and I've authored a couple large sections of the Redux documentation. But if you haven't heard of any of those things I've done, then it's possible you might know me as that guy with the Simpsons avatar. Been using that one for a while. It's still sort of a running debate how much I actually resemble that. Most people point out that my skin is not exactly that shade of yellow, but at least a little bit of a resemblance. So a few quick notes about the talk today. The code samples use some of the latest and greatest JavaScript syntax. Note that this is not required to use React or Redux, but it does make the code a little bit shorter, which also means that it can actually fit into the slides at times. And along with that, I did have to kind of squeeze in some of the code, so it's not exactly production quality, but hopefully it'll give you the idea of what I'm trying to show. I am very biased about React and Redux. There's plenty of other tools out there that are great, but these are the ones I like, so a little bit of bias there. Don't worry about trying to write down links or anything. I will have the slides published on my blog later today, and I believe they said that there will be a tweet going out with links to all the different slides from everybody. And also, don't panic. I will be throwing out a lot of terms and concepts and ideas. You are not expected to understand everything within this 35 to 40 minutes. There is a learning curve for a lot of this material, and I'm going to try to introduce you to a lot of ideas very quickly. Pick up what you can now, go back later, read the docs, go through some articles, let it sink in, and you'll be able to go forward. So, first off, what is Redux? We're going to start with a little bit of a history lesson. Before Redux, there was something called Flux. Facebook announced React in 2013, and a year later they came back and said, we've been looking at how we organize data management in our applications, and we've found that libraries like Backbone, where you have lots of different models that can each be changed separately, don't really scale very well. If I have one model over here, many different parts of my UI could be listening to changes on that model, and if one part of your code changes the data, it could trigger a ripple effect of changes throughout the rest of the application. And it can be hard to trace where, when, and why that data actually changed in the first place. So they said, we've come up with a pattern that we're calling Flux. And we're going to try to simplify the flow of where, when, and why updates actually happen. So the concept of Flux was that you divide your data into these things called stores. So maybe in a blogging application, you would have a users store, a posts store, a comments store, but the rest of the app isn't allowed to go in and change that data directly. Instead, there's a single central point called a dispatcher, and whenever you want to update some data, you call a function called dispatch, and you pass in a plain JavaScript object called an action. The dispatcher passes the action on to all the stores update themselves, and then they trigger some change events. So there's a centralized starting point for any updates to the data in your application. Now, when Facebook announced this, they published a small utility to help with the Flux pattern, but then after that, dozens of different people began implementing their own Flux libraries that followed the same basic approach, but with different implementations. And most of them had really bad jokes as the names based on various Back to the Future concepts. So a year later, a guy named Dan Abramov came up with his own Flux-based library called Redux. And he originally created it for a conference talk where he wanted to demonstrate this idea he had called time travel debugging. Of course, when he came up with the idea for the talk, he didn't know how to implement that yet, but he went off and built it. And Redux took off, and it became much more popular than Dan ever imagined. And it's now the most widely used state management library for React applications. So here's some phrases that I would use to describe Redux. On the docs page, it says, it is a predictable state container for JavaScript applications. I like to refer to it as Flux taken to its logical conclusion. And a really good quote I found is that it's a platform for developers to build customized state management for their own use cases while being able to reuse things like the graphical debugger or middleware. So, two key aspects. One, Redux wants to make your data usage predictable. And it does that by asking you to follow some certain restrictions on how you handle the data in your application. And so the Redux docs talk about these 3 principles. And the first one is that your application should have a single source of truth for its data. That means that you don't have multiple copies of a certain piece of data spread throughout your application. You put as much of the data as possible into a single place, and then even within that place, you really shouldn't have duplicate copies. Now, how much of your data you choose to put in that is up to you. You don't have to literally put every value into this, but some people do. The second principle is that your state should be read-only to the rest of your application. In Backbone, it might be common to have some UI component calling model.set and changing some data. And you could do that anywhere in the application. Redux says no. All the application update logic kind of lives in this one central location, and the rest of the application can read the current values, but it's not allowed to go in and change the values directly. And the third big principle is that all the logic for updating this data should be made with pure functions that don't modify anything else in the application. And these functions are called reducers. And we'll talk about that in a little bit. So the other big concept is that Redux is centralized. We're putting as much of the data in your application in one place. We're centralizing the logic for updating that data. And because the logic and the process of updating it is in one place, that means you can do a lot of things like logging all the changes that happen in your application, or implementing undo-redo capabilities, or persisting the data for when the user reloads the page, this concept of time travel debugging, or even being able to take a snapshot of the application state if the user encounters a bug and send a crash report back to your server that says, here's exactly the data in the app at the time it went wrong, and here's the steps the user took leading up to that. So why would you want to use this with React? We've already heard that in React components, you can have state data in your components. Why do you need anything else? Well, you can absolutely build an entire React application with just React component state, but there are benefits to moving some of that state outside the React component tree. One of the most powerful concepts is this idea of time travel debugging. Because we can log all the different changes that occurred in the application, we can not only go back and see what did the data look like at that point in time, and therefore what did the UI look like, we can actually pretend that some of those actions never even occurred and change the history of what happened in the application during development. This is a really powerful tool for being able to work on your app. Another big thing is being able to share data across different parts of your application. The React docs talk about this idea of lifting state up. If two different components need the same data, you should move it up into a common parent so the parent can pass the data down as props. Well, if you have very widely spread components that need the same data, you might kind of wind up lifting all that state up to the top component in your tree. So Redux can be useful for moving that data outside the tree, and then any component can say, here's exactly the data I need from the Redux store, and extract just what it needs to be able to render itself. There's also a very powerful development capability called hot module reloading, which is enabled from certain tools like Webpack. And this is the idea that if I make a change to a component file, the build tool sees that I've changed the file on disk, recompiles it, and sends the new version of that component up into my running application, which can swap out the old version of the component for the new one. That's great, but if you swap out a React component, all of the state that were in those components goes away. Well, if the data is being held outside the React component tree, you can swap out the component, render the new one, and it's still getting all of its data. So it's basically like live editing your UI tree, which lets you iterate really quickly. So let's look at some of the basic concepts of Redux. We had some talk earlier about some of these JavaScript array methods. Feather touched on some of these. This is kind of an important prerequisite for a lot of the stuff we do with Redux. So some very common JavaScript array methods. The first one is map. We loop over an array, we give it a callback function. The callback runs once for each item in the array, and it creates a new array with all of the values we returned. So in this example, we have a callback function that doubles a number. And if I map over this array, that we go from numbers of 3, 5, 8, 10, 13 to 6, 10, 16, 20, and 26. Filter returns a new array containing some of the original items, but just the ones where the callback returned true or truthy. For each lets us loop over the array and kind of do whatever we want. This is something you might do with some side effects like logging stuff out to a console. And then there's this method called reduce. Reduce is used when you have an array of values and you want to convert that into one final value in some way. So for example, if I wanted to add together all the numbers in the array and get the total, I can use the reduce function. And the callback for a reduce function takes two arguments. The first one is whatever it returned the last time, and the other one is the current item. So we call reduce, we pass in the callback, and then we also pass in what that last value should be the first time. So in this example, if we reduce over the array, the first time the add numbers function runs, last result is 0, current value is 3. And we're going to return 0 plus 3 is 3. We loop through it the second time. Last result was 3, because that's what we returned. Current value is 5. We add them together, we return 8. We go through it again, 8 plus 8 is 16. We go through it again, 16 plus 10 is 26. We go through it again, 26 plus 13 is 39. And the final result is 39. Now notice that this reduce callback doesn't care what the last value was, what the current item is. We pass in something before, something now, and we return a result. This is the important concept behind Redux's reducer functions. So, key concepts of Redux. The first one is that Redux State is plain JavaScript objects and arrays. It's not classes, it's not models, there's no setter methods. You just store basic JavaScript data all together, usually combined into a parent object at the top. So in this example, we have our classic to-do application. And so we're storing an array of to-do entries and a flag saying how we want to filter the list. So then we have actions. And an action is simply a JavaScript object with a type field that describes something that occurred in our application. You could think of them as events or commands. So we might have an add to-do action that has the text of the new to-do entry, or a toggle the checkbox on the to-do action with the index of which one should be flipped, or a set the current filter action that says, do we want to show all of them, show completed, show uncompleted. You'll also commonly see functions called action creators, and these are literally just functions that return an action object. You don't have to write these functions to use Redux, but most people do to try to kind of encapsulate the process of creating action objects. So, the core of Redux is reducer functions. And these are the exact same idea that we saw with the array reduce method. So reducer functions take two arguments. The first one is the current state value, and the second one is the current action object. And a reducer function looks at the previous state, the current action object, and says, what should the new state be in response? So for our to-do application, we have two reducer functions up here. For the visibility filter, we just want to say, was the action type set the filter? If so, the new filter value should be whatever was included in the action. If it's something else, well, we're not changing the filter. We want to keep whatever the current filter value is. So we'll just return that. Then we have our to-dos reducer, and we're tracking an array of to-do object entries. And so we've got three behaviors we can do in here. The first is add a new to-do entry. And so when that action is dispatched, we're going to return a new array that contains the new to-do object at the end. If we toggle a to-do, and we're clicking the checkbox on one of the entries, then we need to loop over the array, return a new array object that has all the same to-do entries except for the one that's being changed. And it's one of the key things that trips up a lot of people is you can't go in and change the data that was there already. You need to make copies of the data and update it immutably. So instead of calling, for example, state.push, which would modify the existing array, we call state.concat, which makes a copy of the array with the new item added onto the end. In the same way, for toggle, we're going to map over the array. We're going to return all the old items except for the one that's being changed. And for the one that's being changed, we're going to make a copy of that object and return the copy. And similarly, for the remove to do, we'll use filter and return a new array that just leaves out the one that's being removed. Now, we had two small reducer functions, visibility reducer and to-dos reducer, but we need to combine those into a bigger function. And because reducers are just basic JavaScript functions, this function can call some other functions to do some of the work. And so we normally have a parent reducer or a root reducer that calls some other reducer functions to do the real work of updating everything. And then we combine the results into the final state object. And because this is such a common pattern, Redux includes a utility called combine reducers that makes it really simple. So we say that we're going to have a piece of our state called to-dos, and we're going to use this to-dos reducer function to update that data. We're going to have a piece of our state called visibility filter, and we're going to use this visibility reducer function to update that. So here's where it all comes together. Redux has this idea of a single store that holds your data in the application. And we have a function called createStore that creates a store object. So you import createStore from Redux, you import your root reducer function, and you pass that to createStore. And stores have 3 functions that you can work with. The first one is dispatch. And this is where you pass in those action objects that we saw earlier. So I can say store.dispatch, set visibility filter, and then that visibility reducer kicks in and it says, oh, hey, I should save whatever filter value you gave me. The second function is getState, and it literally just returns whatever the current state value is that's inside the store. And the third function is subscribe, and you can give the store a callback function, and every time an action is dispatched, all those subscriber functions will run. So in this example, we start off by creating a store with our to-do application. And we can also pass in some initial data that we want to use. So let's say we passed in an initial data that had 2 to-do entries. So the first time we call getState, we've got some array of to-dos here, and maybe we set it to show just the completed ones by default. So we dispatch an action that says set the filter to show all. And when we call getState again, and that did not help. There. I should be careful and not accidentally zoom in. So after we dispatch an action, we can get the state again, and we can see that the new state value saved whatever the filter value was that we said it should be. So we can get the state, and then we can check and see how many to-dos do we have. We have 2 because we shoved in 2 when we created it. And then I can add a subscriber callback that will run after we dispatch and log out the number of to-dos after the action was dispatched. And if I dispatch add to-do, now it says, now we have 3 of them instead. So we write action objects, we write reducer functions to do the updates, we create the store and give it the reducer function, and we dispatch actions to cause updates. So we've heard already that in React, the data flow is kind of supposed to be one way. Parent components pass data as props down to their children. And in Redux, we have a similar bit of behavior. So let's trace this data flow through the circle. So we have a user interface. This particular GIF appears to be some kind of a banking application. And so we've got some buttons in the UI to deposit money or withdraw money from a bank account, if only it was that easy. So let's say the user presses the deposit button. We're going to dispatch an action to the store that says, deposit some money in my bank account. So the store is going to run the reducer functions with this action. The reducers provide us with an updated state value, and the store runs the subscriber functions. The subscriber functions are probably hooked up to our user interface, and they say, oh, an action was dispatched, some data has changed, let's redraw our user interface with the new data. And so it's a big circle. Notice that the UI is not changing the data itself, it's telling the store something happened. The store says, okay, I updated myself, you should probably check and re-render, and it's a big circle. So how do you use Redux with React? Well, you can actually use Redux with any user interface library. Redux is not React specific. You can use it with Angular, Ember, Vue, jQuery, vanilla HTML, or in JavaScript, anything that you want. But it is most commonly used with React. And so there's a specific library called React Redux that hooks together a Redux store and your React components. React Redux gives you a function called connect. And connect auto-generates new React components that manage that process of talking to the store for you so that you don't have to write that code yourself. They also make sure that your components only re-render when the data they need actually changes. So I can call connect, wrap up one of my own components, And then I put a component called a provider at the top of my application. And that makes the store accessible to any of these connected components in my component tree. So here's a quick look at what using connect looks like. So we import connect from React Redux. We import one of our own components, still going with a banking example here. We import, in this case, an action creator function and a selector function that helps us retrieve data from the store. We write a function called map state to props, and this will be called with the entire Redux store state as an argument. And we can pick out all the pieces of data this one component needs and return an object. And each of those fields becomes a prop on the React component. So the component would have this.props.balance and this.props.latest transactions. We can also write a function called map dispatch to props, and this lets us dispatch Redux actions from within our React component. Finally, we call connect. We pass in the map state and map dispatch functions. And then this is actually a double function, so we pass in the React component that we're trying to wrap up. There's also a little shorthand for the process of hooking up dispatching actions. You can put them in an object and pass them as a second argument instead of a separate function. A couple other topics I want to go through quickly. Redux by itself is synchronous. And so when I call dispatch, it runs the reducers, saves the new value, runs the subscribers, done. So where does Ajax stuff fit in? Well, to understand that, we have to look at this idea of middleware. We said earlier that Redux is centralized. And so that means we can, if we wanted to look and know what actions are going through the system, there's one place we can go to check that out. And so Redux lets us define these add-ons called middleware and kind of wrap them around the store so that when I dispatch an action, it actually has to go through all these middleware first. So for example, maybe I want to log out every action that I've dispatched. Well, I can have a middleware that logs out the action and then passes it on to the next middleware in the chain. And so these form a pipeline around the process of dispatching, and it's a centralized place where we can add extra behavior to the store. So a middleware can do anything it wants with an action. It can pause it, delay it, modify it, log it, do something else entirely. So middleware are a very powerful way to customize behavior of the Redux store. Here's a quick example of what writing middleware looked like. The example there looks more complicated than it actually is. But so in this example down here, this would be a logging middleware. So every time an action is dispatched, we can log what the action is. We can pass it onwards. And by the time we get back, we can log out what the state was after the action was dispatched. So I said a minute ago that a Redux store is normally synchronous, but we need to do Ajax behavior, we need to do timeouts, and especially if we're making Ajax calls, we probably want to dispatch actions to load the data after the call comes back. And so we call these side effects, and this is a term from functional programming. Basically means anything that affects the outside world other than my functions and code that are running right here. So with Redux, we kind of push the side effects off to the side from the store. Middleware give us a bit of a loophole where we can run side effects, do async behavior, and still talk to the store somewhere in that process. There are many different libraries out there to add side effect behavior to a Redux store. Two of the most popular are called Redux Thunk and Redux Saga. My advice would be that for most people, Redux Thunk will be enough. It basically lets you pass in functions to the store instead of actions. And then inside of it, you can kind of do whatever you want. So I can make an AJAX call, and when it comes back, I can dispatch a data loaded or request succeeded action. Or I could maybe check the state and say, I only want to dispatch an action if a certain thing is true. Sagas use generator functions to do some very powerful asynchronous behavior. It's really cool, but most applications probably won't actually need that. So what does some of this stuff look like in practice? I added this slide at the last minute based on some conversations I was having. There's been a lot of chatter on Twitter and blogs and a whole bunch of different places saying that Redux is about to be replaced or Redux is dead or no. No. Redux is not being replaced. Redux is not being deprecated. Redux is not a Facebook project. Its creator, Dan Abramov, now works on the React team, but it's a separate open source project. It's widely used. It's not about to go away. Now, I will say that the new React context API that's coming out soon will potentially solve some use cases that people might have used Redux for already. So if you had some data and you just want to pass it to deeply nested components without passing it as props all the way down, the new context API will make that simpler. You don't have to use Redux just for that, but there's many other reasons to use Redux besides just shortcutting passing down props all the way. The React Redux library currently uses the older style context API. We are in the process of trying to update it to work with the new context API and also to work better with some of React's asynchronous rendering capabilities that will be coming out later this year. So just want to be very clear, it's not being replaced. So, but this does bring up the question, when should I learn Redux? When should I use Redux? And both the React team and the Redux team would say, you should probably focus on trying to learn React well first, and then try to tackle Redux. There's nothing wrong with doing them both at the same time if you want to, but for most people it's easier to focus on one technology at a time, fewer terms, fewer buzzwords, and once you've gotten familiar with how React works, you'll better understand why a state management library like Redux can be useful. Now, a lot of people have complained about, with Redux, I have to write a lot of extra code. Well, number one, Redux was not designed to be the shortest way to write code. It was designed to help you understand when, where, and why your data is changing in your application. So some rules of thumb for when you might want to use Redux in an application. One, you have some data that's changing over time. Now, how much is reasonable is kind of up to you. You might want to use Redux from the start. You might want to hold off till your app gets bigger. Another rule of thumb is you want to have a single place where most of your app can go and find data rather than having little bits of data spread over your whole code base. Or a third rule of thumb would be if you found that all your data is kind of migrating into your top component and now it's getting too cluttered, and you'd kind of like to move that outside your component tree. Actually, that's the next slide. Dan Abramov has actually spent more time telling people not to use Redux than he has trying to promote it. And in fact, about a year after he published Redux, he wrote an article saying you might not need Redux. And in this post, he says, Redux asks you to make trade-offs. And if you follow these trade-offs, you can get some great benefits. But if you don't need those benefits, maybe you don't need Redux. So I will say that I think a lot of people are told to use Redux right away without really understanding or without really being told, here's the reasons why you should use it. People just say, these are the things that go together. You should do it this way. Take some time to understand the benefits that it can give you and understand whether that's actually going to help your own application or not. Similarly, if you're using Redux, you don't have to put literally everything in your Redux store. You can still keep data in React components. The classic example would be, is this drop-down open or not? If the rest of the application doesn't need to know about it, it probably doesn't need to go in Redux. That can stay local to that component. And so there are some rules of thumb for when it might make sense to put certain data into the Redux store. By the way, this section is in the Redux FAQ, and there's a bunch of additional information there that would probably be useful as well. Now, Redux itself is a very, very small library. If you strip out all the error handling, it's probably about 100 lines. But it was designed to be very extensible. And so there's hundreds and hundreds of different add-ons and utilities and libraries that help make it more useful for different situations. Things like fetching data from a REST API, or managing complex asynchronous logic, or persisting data from your store between page reloads, all kinds of different add-ons so that you can customize it for your own situation. And there's a Redux docs page that lists some of our recommended tools, and then I have a much more complete listing as a separate repository. Okay, I've got 5-6 minutes left. On my blog, I've been writing a tutorial series called Practical Redux. And in this series, I've been building a sample application that tries to show you some patterns and ideas for using React and Redux that you might not see just in the documentation themselves. And so I want to show you this application real fast and show you some bits and pieces of what this looks like in practice. So I'll flip over to the example application. And in this app, this is it's based on a game universe, and we got a fictional combat organization. You can think of it as like a fighter pilot squadron, except that instead of like flying aircraft, they're driving these big stompy robots with weapons. So I'm going to load up some data. And so we can see that we have, the name for this group, the logo color for this group. We've got the different, subdivisions of the pilots and the types of robots that they fly or drive, as the case may be. And over here, we have a list of the pilots. We have a list of their robots. And so we've got a bunch of different data. And I can come in here and I can select an entry in the pilots list. I can start editing them, and these different buttons change state. I can start editing the pilot, change the name, give him a different rank, give him better shooting skills. Notice in this example that the work in progress values in the form are still separate from the original values over here in the list. And if I hit save, now the list is actually updated. So let's see what actually happened in the background there. So I'm going to pull up the browser's development tools. And I don't think anyone has actually mentioned this yet. How many of you have not used the React Dev Tools or the Redux Dev Tools before? Have not used them. Okay, so it sounds like most people are familiar with them. For those who are not, these are plugins for both Firefox and Chrome that will show you the React component tree and the contents and the history of your Redux store. So I can look at my Redux store and see that when I started, this was my entire Redux state tree. We have an area in this example that's kind of like a little mini client-side database of all the different entries that could be loaded. We have an area that tracks what is the current selected pilot, are we editing them, and what is the currently selected tab in the user interface. So I clicked the Tools tab first, and I dispatched an action of type tab selected, and I said that the selected tab should be the Tools tab. When I dispatched that action, this was the change to my state tree. The state.tabs.current tab section changed from the unit info tab to the Tools tab, and I can see the complete state tree after that action. When I loaded up the data, I dispatched a data loaded action that contained a bunch of information about this fictional unit that I'm going to edit. And we loaded all that data into our little client-side database section in the Redux store. So then I clicked a few more tabs, and then I selected a pilot. And so the current pilot value changed. And then I started editing the pilot, and I made a copy from kind of the current section of my state to the work in progress section. And so then as I began editing the pilot, so for example, I changed the last name of the pilot, I updated the value of that copy in the work in progress section. And so when I got done and I hit the save button, I copied all these work in progress values back over to the original entry and updated those 3 fields. So notice that I'm going back through and I can see what actions occurred, what the contents of the actions were, how my state changed, and what the state tree looked like afterwards. So now let's actually kind of backtrack on some of this. Let's say that I never actually clicked the stop and save button. So I'm going to undo a couple of these actions. And as I undo these actions, notice that the form is now active again, because as far as my application is concerned, I never actually hit the stop button. So I've just gone backwards in time to an earlier state. And so maybe now I want to change this to real for real last name instead and save that. So I kind of backtracked, undid stuff, and went in a different direction. And so this is very, very powerful for working on your app. And I am about out of time. So last couple thoughts. React and Redux are a very powerful combination for building apps and being able to have very, very predictable behavior for how your data is updated, how it's organized, and what your UI looks like as a result. Both of these libraries push you towards functional programming principles, but without locking you in to very rigid patterns. And both these libraries have very big ecosystems with lots of other add-on packages that you can use. My slides, as always, have links to many, many resources at the end. Again, I'll have the slides up on my blog shortly thereafter. I've got links to official documentation. I've got links to my own suggested resources for learning React and Redux. The last link here is for a chat room called Reactiflux. It's a place for React-related discussion and topics. I hang out there all the time. There's a ton of people happy to answer questions. It's a great place to hang out and learn. And I spend a lot of time reading and writing about React and Redux. So here's some of the things that I've written as well. If you got questions, chase me down afterwards, ping me on Twitter or Reactiflux at AceMarkE, and I'm always happy to try and point you in a good direction and answer questions. Thank you.